In the China-Burma-India theater, engineers built or supervised the building of many different types of fixed bridges. The crudest was the primitive type footbridge, made from jungle growth with the very minimum of tools. Then there were these temporary fixed bridges made with a log deck on rock cribs. For this swift current, pile bent seemed like a good bet. So an engineer using a dozer and A-frame rigged up a pile driver. It did the job. And here's the completed bridge. This type won't take heavy loads, and it won't stand up under heavy traffic. To do those jobs, engineers depended mainly on their old standbys, the timber trestle, and pile bent bridges. These bridges require sawed timber. Native methods were much too slow. This is a good way to develop large chest and back muscles, but a one-way native saw produces very little bridge lumber. The elephants keep pace with the sawing. They're a colorful means of transportation, and they're steady, but awfully slow. This powerful animal can be trained for heavy and specialized work. He can pull timber through the jungle, pick up heavy loads and pile lumber, but he can't be hurried. So the native methods of lumbering could only be relied upon for a small part of the sawed timber needed for fixed bridges. As soon as equipment was available, engineers started logging the American way. Sound, straight trees about 2 feet in diameter were selected. Then the gasoline chainsaws chewed through the trees in short order, and the timber crashed to the jungle floor. After the logs were trimmed and the tops cut off, they were hooked on a tractor and snaked out of the jungle. It isn't good practice to drag logs through mud, but because of the heavy rainfall in this country, it was muddy everywhere, for months at a time, and the job had to be done. Logs were snaked out to a road where they were sawed into shorter lengths so they could be loaded on trucks. A tractor crane picked up the logs and swung them around to the bolster-type trucks. Then, with a full load, the trucks pulled out for the portable sawmill, which had been set up nearby. After the logs were unloaded, one man measured their diameter to determine what size lumber could best be cut from them. Other soldiers, using peavies, rolled the logs up onto the carriage and locked them in place. With the large circular saw buzzing, the carriage was fed back and forth. This mill is turning out heavy floor planks without taking time to trim off. In the CBI, sawed timber like this really looked good to the engineers. It speeded up the process of bridge building and gave them a chance to build sturdier and heavier bridges. There were some big jobs to be done. Here's a stretch of road 10,500 feet long that had to be raised 9 feet above the lowest spot in the old roadbed, so the monsoon rains would pass under the roadway, not over it. This called for a pile-bent causeway. For this job, power shovels with pile driver attachments were available. 2 pile drivers worked together, one on each side. This saved time since it wasn't necessary to raise or lower the boom for each position. After the pile was snaked into the leads and positioned in the follow block, the hammer was freed and the driving began. A lot of piles had to be driven for a causeway as long as this one. Here's the same area after only a light rain. There should be no doubt as to why a causeway was badly needed here. After the piles were driven, another crew came along to cut them off evenly. A level was used to maintain a uniform grade. Batterboard nailed to the posts marked the height and was used as a guide by the chainsaw gang. A sloppy job just won't do here. The piles have to be cut off square and in line with the others, or the load won't be distributed evenly. And this is the next part of the job, placing the cap on the pile. A quick-way crane made up for the lack of manpower. It lifted the caps into place. To fasten them to the piles, a pneumatic drill bored the holes, and then a nail driver was used to drive the drift pins through the caps into the piles. Now for the deck. Trucks hauled the stringers and flooring up alongside the causeway. Then a quick-way crane on top of the completed part lifted the stringers into place. After the stringers for one span were laid, a bundle of floor planks was hoisted onto the causeway. Men using handmade cant hooks slid them into place. After the deck in each span was laid, the quick-way moved forward to tackle the next span. And it wasn't too long before thousands of feet of pile-bent causeway had been completed. The engineers in the CBI weren't limited entirely to timber construction. Here are two baileys side by side to provide 2 lanes of traffic. This short bailey had to be reinforced near one end by a timber trestle. In this pile-bent bridge, H-20 box girder steel trusses were used over the long span. Over on the Chinese side, some of the through truss bridges had to be repaired by native labor under engineer supervision. An unusual type of bridge construction is this combination pedestrian, railroad, and highway, a 3-in-1 job. The Salween River, with its high, steep banks, presented quite a formidable obstacle. The Japs had destroyed the existing cable suspension bridge. The masonry towers on one side were okay, but the base and towers on the other side had been completely demolished, so the first step was to rebuild them. American and Chinese engineers put their heads together on this one. Coolies supplied the manpower. First, this walkway, suspended on 2 cables, was stretched across to get materials over to the far bank where the bases and towers had to be rebuilt. Hand-hewn timber was used to construct the towers. It was a slow job using native methods, but when there are enough of them, the job eventually gets done. It's surprising how much these coolies with a pole across their backs can lift and carry. As soon as the towers were completed, the cable seats were hoisted up by means of a block cable. The masonry towers also were prepared to receive the main cables. Most of the cable had been salvaged from the original bridge. Other short bits were hauled in to replace what was lacking. With the cable seats in place, the main cables were strung. Getting a 2-inch cable over the towers and across the river presented quite a problem. Good solid anchors were needed on both sides. Concrete was keyed into the solid rock of the mountainside, and the cables fastened to bolts seated in the concrete. To complete the job, slings were attached to the main cables. Cross beams, stringers, and flooring were laid. There wasn't enough cable, so steel hangers were used to fill in on one side. The floor planks were laid diagonally to give the deck greater stiffness, and treads were placed to provide a wearing surface. This bridge and the others you've been shown are just a few examples of the many different jobs in the CBI that will test the skill of any engineer. To be successful under these conditions, you'll need a sound background in the basic principles of bridge building, together with resourcefulness and ingenuity.